Okay, so what is the payoff to all of these rules? Well, certainly we can use them on their own individually, but we can also bundle them up together into something that your textbook calls the direct substitution property. And boy howdy, is it handy. So I can say, if f of x is any of the following, then when I calculate the limit as x approaches a of f of x, this is just going to be equal to f of a. So this is a catalog of very nice functions, at least as far as taking limits is concerned. So, what are my very nice functions? I'm going to say if f of x is a polynomial, then I can use direct substitution. If f of x is a rational function with a not an asymptote of f, then I can use the direct substitution property. And I'm going to go a little bit further and say that radical functions also enjoy the direct substitution property. And the sine and cosine functions. So if f of x is a polynomial, a rational function, a radical, a sine function, or a cosine function, and you wish to calculate its limit, we can just evaluate at the coordinate a. So let us take the limit as x approaches pi. The function I wish to compute is the cosine of x plus 1 divided by x plus the cube root of x. Well, this function, this whole formula I've got here is not a polynomial, and it's not a rational function, right? Because it's got some cosine stuff in here. It's not just a radical because it's got the division and all that. But I can go back to my limit law number 1 and say this is the sum of 3 different functions. So I will calculate these limits separately. So I have the limit of the cosine of x as x approaches pi. I have the limit of 1 divided by x as x approaches pi. And I have the limit of the cube root of x as x approaches pi. And I'm going to calculate those limits all separately from one another, and I'm going to add the answers together. So here I can just say the limit should be the cosine of pi, because pi is one of my direct substitution functions. That's a little unwieldy. We'll have a shorter name for that later. 1 divided by x is a rational function. Pi does not cause the denominator to go to 0, so I can say that the limit here is 1 divided by pi. Here I've got a radical, I've got a cubic root, so I don't even need to worry about positives and negatives. So I can just say the answer here is going to be the cubic root of pi, and I'm going to add those all together. So in my usual way, I'll say that this formula is the final answer, and it's the most useful form, at least to me as a teacher, because I can see exactly where this cosine came from. I can see exactly where this 1 divided by pi came from. And I can see where the radical, the third root of pi, came from. It helps me out when I am grading, and it helps me out when I am trying to figure out what my scratch work was supposed to say, because maybe I'm looking at this again a couple days later and it's not fresh in my memory anymore. But the cool thing about all of these rules now is we have a much simpler way to calculate derivatives of fairly familiar looking functions, even ones that we combine in strange ways.